Good day, everyone. And once again, we are back together, okay? And this time we are looking at physics. And of course, I'm imagining that most of you have already written your maths exams. So if you haven't subscribed, please just make sure that you are part of the family. All right, and of course, we'll be looking at physical science as well as chemistry in the next few days. Right, so we're looking at vertical projectile motion. Right, I took this from the prelim, Gauteng prelim, I believe, 2022. Right, let's get right into it. Right, so it says a cricket ball is projected upwards from the bottom of a building from point A. Please don't mind, my voice sounds a little bit different. I've been talking a lot, so yeah, it just feels a little bit, it's been affected somewhat. All right, so it says from point A at a velocity of 20 meters per second, it reaches a maximum height above the building and returns to point B as shown in the diagram, right? Now they say to us a man standing on a balcony of a building at point A catches the ball 1.66 seconds rather after it has reached its maximum height, right? And of course they say we should ignore the effects of friction. Right, now, of course, the first question, the definition, define the term free fall. We know that this is motion under the influence of gravitational force only, right? Of course, you can express it in however way that you like. But remember, what needs to stand out is the fact that gravity is the only force that is acting. Right, so they say to us, calculate the time it took the cricket ball to reach its maximum height. So what I want us to do is let's have a look quickly at what happened here. Right, so we had a ball that was projected from A and it went all the way up, okay, and of course it came back to the balcony. All right, so here's our balcony area. So they've called this point where the ball was projected from A, and they've called this point B. So what I want us to do is have another point there, the maximum height. Remember, they did say that it passed that balcony and then it came back. All right, so let's call that point C if you don't mind. Okay, right, now what we are looking at, they want the time that it takes the ball to get to point C, which is that maximum height. So let's take, in this case, our information from A till C. Okay, so I'm going to take from A till C. So in this case, remember, I'm going to choose upwards as positive, right? There's nothing wrong. Should you choose to take downwards as positive, nothing wrong with that, right? But I'm just going to take upwards as positive. Now, we know the ball was projected at 20 meters per second upwards, right? So it means that its initial velocity in this case would be positive 20, right? And why is it positive? Because we've chosen up to be positive. Right, and when it gets to point C, that maximum height, we know that it will stop momentarily. So the velocity is 0. And of course, gravitational acceleration will be negative 9.8. Why is it negative? Remember that gravity always pulls downwards, right? In this case, so as a result, because I've taken up as positive, it means that down will, of course, be negative, right? So the time that it takes is unknown to us. Please be careful that 1.66, they did say that, this is from the point, from the maximum height in this case, up until the man catches it, right? They said a man standing on a balcony of the building at point B rather catches the ball 1.66 seconds after it had reached its maximum height. So we need to be very careful about that one, right? Okay, so meaning that time is the time from C till B. Okay, so that's the 1.66. That's where it actually features, right? Okay, so as well as the displacement in this case is unknown, right? So they wanted us to calculate the time. Okay, so please remember we've got four equations of motion, right? And all of them are unique. In this case, there's only one equation, right? Because we're not given a displacement in this case, and we want time. So it means whatever equation we take has to have time, but there's only one without displacement, and that's the first equation, right? So in this case, I'm going to say Vf is Vi plus G delta T, right? So in this case, okay, let me just take this down there, right? So that I have a little bit of space. Right, so in this case, I'm going to just substitute. We know our final velocity, we said it's 0. Our initial velocity is going to be 20, but we've got negative 9.8 delta t. Now, please remember, we do some mathematical gymnastics. So minus 20, that's negative 9.8 delta t. Okay, so that's negative 9.8. Okay, we divide by that, and of course we'll get time. Now, ladies and gents, at this stage, I do want to caution you to some extent. So please be careful. If you ever get a negative time, all right, it only is an indication that there is something perhaps wrong that you might have done in your approach. So please be careful. Go back to your calculation and see where there's an incorrect substitution. Instead of getting when you get a negative time, don't say therefore time is positive, all right? In this case, it's an indication that there's something in your substitution that you did not do right. Just go back and make sure that you fix that, okay? Right, and then they say to us, calculate the height of the balcony above the ground. Now, I'm going to show you two ways in which you could approach that question, right? So I'm looking for the height of the balcony. So what I can do is I can find out what the displacement is from A to C, right? And also find out, now remember it would be that entire height there, right? And thereafter find out the height from C to B, right? And in this case, what would that do? Of course, this displacement from A till C, okay, let me call it YAC, and this displacement from C to B, YCB, right? In this case, when I add them from each other, obviously the one will be positive and the other negative, right? So when I add them, I take the vector sum of them. In this case, I will get the displacement from A to B. So that would be the first way, right? So 5.2.2. So I'm going to say, well, I'm taking my displacement from A to C, right? Now, remember, I already have information from A to C, so I can use that quickly. Okay, so I can say, so that's Vi delta t plus 1 over 2 times A delta t squared, or in this case, you can use any of the equations to find the displacement. So that's 20 times 2.04 plus half into negative 9.8 times 2.04. Remember, that's the time that it took to get to that maximum height, right? So that's 20 times 2.04, okay, plus 0.5 times negative 9.8 times 2.04 squared. Okay, right. I get 19.6. All right, so that would be 19.6 meters. Okay, and remember, it would be positive in this case because it was displaced upwards, right? So, and then I can calculate the displacement from C to B. Right, now remember, when I take the displacement from C to B, it means that C is my initial velocity, right? So it means that the velocity at c would be 0. I don't know what the final velocity is when it gets to the balcony, but I do know gravitational acceleration, okay? That's 9.8, as well as the time being 1.66. You remember that that was the time that we got, isn't it? So I can say, well, using the very same equation, okay, plus half a delta t squared, in this case, that would be 0 multiplied by t, which is 1.66, plus half times negative 9.8. Please remember, gravity does not change direction. Okay, so the acceleration obviously would still remain negative because we've chosen up as positive, right? So that would be 1.66 squared. Okay, so let's do that quickly. So that's 0.5 times negative 9.8 times 1.66 squared. Okay, and I get minus 13.5 meters, right? So now, to get the total displacement, remember, in this case, we wanted to find out how far the balcony is, right? So the height of the balcony would be the sum of those two displacements. So that would be 9.6 plus negative 13.5. Okay, right. So in this case, sorry about that. So in this case, I am going to get 6.1 meters as my final height. Okay, so that would be the first way of approaching this question. Now, what would be another way? All right. Yeah, let me just make some space. What would be another way of tackling this question? So what you can do is remember when the ball was projected upwards, right? It went from point A and all the way up until point B. So I know that at A my initial velocity is 20, okay? And I know in this case when it got to the balcony, remember it went up 2.04 seconds, but it also went down an additional 1.66 seconds, right? So if I take information from A till B in this case, that would be, okay, if I say my initial velocity would be 20, final velocity still unknown to us, okay? If I take gravitational acceleration, that's 9.8, negative 9.8, but the time there in this case would be 2.04 plus the 1.66. Okay, I believe that would give us 3.7. So that would be 3.7 seconds. That's the total time of flight of this ball, right? And in this case, we'd be looking for the displacement. Now remember, by definition, what is displacement? It's a straight line change in position between the starting position and the end point, between the beginning and the end point. So where's my beginning? It's at that point. Where's my end point? Right over there. So it means by using all of that information from A to B, the total displacement would actually be the total time. Would be the height of the balcony. Okay, right. Now, we can use, of course, we don't have displacement in this case. Actually, we want displacement. We don't have final velocity, right? So I'm going to use the only equation again without final velocity. So delta y, that's vi delta t plus 1 over 2a delta t squared. So that's 20 times 3.7, okay, plus a half times negative 9.8 times 3.7 squared. All right, so let's see. So that's 20 times 3.7, okay, plus 1 over 2, which is 0.5 times negative 9.8 times 3.7 squared. Okay, right, so that would give us 6.92 meters, right? Okay, right, which is kind of almost the same answer as that. Did I calculate that correct? In 19.6 minus 13.5, I get 6.1. There's a slight difference there. I'm just wondering if I actually calculated that correctly. Let's see. So I took the so that's 20 times 2.04, and that's plus 0.5 times negative 9.8 times 2.04 squared. Okay, yeah, I see. So I actually got it wrong here. So that was 20.4. Apologies about that. Okay, so that was 20.4 meters. And then obviously I would take that. That's 20.4. Really do find my sincere apologies. So when I take that, 20.4 minus 13.5, right? So that's minus 13. Actually, let me do this. Rather find the answer first and then minus 13.5. All right, yeah, you can see that answer there, 6.91, which is exactly what we found in the 6.91 rather. Okay, 6.91 in this case, which is basically just the same as that answer over there. Of course, what you could have also done is just calculate in this case, or rather take the time difference between the two, meaning the 2.04 and then minus the 1.66. So it would have given you the time that it takes for the first time for the ball to pass this point B. And of course, you'd still be able to get that displacement there. All right, now let's get to the next part of it. Right, now they say to you, calculate the speed with which the man's hand, or rather, with which the ball strikes the man's hand when he catches it. Okay, so we're looking for the velocity when we get to B. So you've got a number of options that you can use there. So remember, we had information from A to B. Okay, so I'm looking for the final velocity. So VF is going to be VI, so that's V 5.2.3. VF is VI plus G delta T. Okay, remember, so I'm taking information from the top, right, which is point C, all the way up until it gets to the man's hand. So that's going to be 0. So the initial velocity was 0, and that's negative 9.8, and T in this case would have been 1.66. Remember, that's the time that it took to get to point C, right? So that would be negative 9.8 multiplied by 1.66, okay? And we get minus 16.27, negative 16.27 meters per second. Now, please remember, why would it be negative? In this case, it means that it's 16.27 meters per second. In which direction? It's going to be downwards, right? So although the question did ask for the magnitude, or rather the speed, so there was no need for us to mention direction in this case, but nonetheless, it is worth noting that the direction was downwards, and remember, we chose up as positive, right? You also could have calculated, from point A all the way up until B, but nonetheless, I won't go through that. Now, please remember, now we're going to draw a graph now, which is the next question. They say draw a velocity time graph for the motion of the cricket ball from the moment it was projected upwards until the man catches the ball at point B. All right. And they show us what to indicate clearly there. Now, it is very important to note that velocity versus time is a vector quantity, right? So in this case, we must actually show both, you know, the positive and the negative side. Of course, not for time in this case, but for velocity, right? Please remember, you must label your graph. So this is velocity. That would be in meters per second, okay? And that would be time. This would be time in seconds, okay? So let's try and do the most. Okay, so my velocity, okay, the highest one I've got is 20. No, actually that's, okay, yeah, actually it is 20. So what I'm going to do is, if you don't mind, I'm going to make my velocity in divisions of 10. In this case, that's going to be my scale. So that's -10 and -20. Right, and for time, my highest time was, okay, 3.7, right? So let's make this 1, 2, 3, and 4, right? So what I'm going to do is I am going to say, right, so right at the beginning, remember, our initial velocity was positive 20. Remember, I took downwards as positive, upwards as positive. So at time 0, my velocity was 20, right? And then I know that we got to a time of 2.04, right? 2.04, that is at maximum height. So when the velocity was 0, the time was 2.04. So it's just going to be next to 2 there. Okay. And then finally, when we got to point B, right? This was the velocity when we got to point B, -16. Okay, so perhaps somewhere there, that was at 3.7, if you remember. Okay, yeah, I can put it somewhere there. All right. Now, all I need to do is just try to connect those points. I don't know if I can do that with my with my ruler there. Okay. We'll try by all means just to get the points to align. Okay. Remember, it's not really drawn to scale, right? Okay, right, but there's what your graph should look like. Okay, right, so please remember, guys, for velocity time graph, that should be a straight line. Just as a, as just an additional, what if they had asked us to calculate, or rather to draw a displacement time graph? Okay, so in this case, what would that look like? Okay, so if I take the displacement time graph, remember there are two types. There's one where I can take the ground as my reference point. In fact, let me do exactly that. If I took the ground as my reference point, then in that case, I don't need to actually show the negative axis, right? Because it can't go below the ground. So that would be position versus time. Okay, so position is in meters and time is in seconds. And in this case, what would it look like? So remember, it would have started from the ground, okay? And I know after 2.0, what was it? 2.04 seconds, okay? So after 2.04 seconds, I know that my position would have been at, what was that? I think we got 20.4 20.4. Yes, that was 20.4, right? And then thereafter, after the additional 1.66, our position would have been 6.91, right? So at 2.04, right, our position was 20.6. So let's say 10 and 20 there. Okay, so at that time, that would be our position. Okay, and then after 3.7 seconds, so if we say this is 3 and that would be 4. Okay, so at 3.7, somewhere there, our position was at 6.91. And what we're going to do, remember, it indicates a parabola, right? That would be the position time graph. In fact, why am I even starting at 10? So it would start from 0. Okay, so that's what my graph would kind of look like. Okay, right, so remember that position there, that was 20.7, and at 3.7 it would be 6.91 or 92 depending on your calculation. Okay, so that's what your position time graph would look like using the graph as your reference point. In fact, let me leave it here and not go any further. All right, I hope that this was helpful, ladies and gents. And of course, we'll do some more questions on graph interpretation. All right, just look out on the channel. Otherwise, from me for now, I will see you guys next time. Sharp, sharp.